We're going to talk about improving some wall performance. We're going to talk specs and QA, quality assurance. Obviously, that was my background. I did that for 13 straight years for a $1 billion contractor. I was all over this country. I've chased leaks all over this country. I've sat in pre-install meetings all over this country. Okay. Looking forward to some discussion. Again, if you guys raise hands, talk, let's have some open discussion. Andrew's presentation with the comments, that was phenomenal. Thank you for participating. Again, it's AIA, copyright. I'll try to be, I'll try to be ethical. Learning objectives. Again, we're going to talk some specs. We're going to look at some understanding of air barrier codes. We're going to talk about why, tightness and a process for quality assurance. Okay. Here we go. We now have the basic equation for air leakage. You guys got it? That's about it. That's what it feels like some days. One of the benefits with ABAA and some of the things we're going to talk about is, the research we do. And we were very fortunate at ABAA to team up with Oak Ridge National Labs and NIST. And we put together what we call the air leakage calculator. The first run at this calculator cost about $140,000 to get put together. We're on phase 2. Phase 2 is only about $150,000, right? Pocket change. Not. But what do? We worked with 52 cities in the US, 5 in Canada, and somehow Oak Ridge suckered 5 out of China to help pay. So that was awesome. What we're doing here is we're taking a look at a location, a building type, and right now we have 3 building types. We're adding more. That's part of phase 2. Along with moisture, Laverne showed you a bar graph earlier today about moisture in walls. That's part of phase 2 of this calculator. Okay, square footage, the base air leakage rate, what you're hoping to hit calculate, and you get some sort of graph coming out. Right? We know moisture in the walls is their number one concern with air leakage. Well, let's be honest, when you talk to owners, they want to know about money. Here's the second thing you can talk to them about. Actually, real quick, you saw how fast and easy that is to work with. A couple clicks and you're there. And here you're seeing, hey, base rate, if we don't do a good air barrier, this is your annual energy use versus a tighter building. Okay, pretty simple. But it's a very useful tool. It's very easy to use. It takes the energy costs from that local area, I believe from the previous year. So you're getting real numbers. Okay. Specs. 01400, quality assurance, front end, right? How many of you have 7 pages in it dealing with air barriers? Yeah, I didn't think anybody's hands were going up. Board stock. How many of you have 15 pages of rigid cellular thermal insulation board stock as your air barrier in your spec? No? Huh. Fluid applied, that's the fun one. 47 pages. Come on, it's in there. We have them, that's part of what's on these flash drives you guys are getting. The fluid, I believe the fluid applied spec is on that one, for sure. If you don't have a lengthy specification and you're seeing these numbers up there, you might want to think about comparing yours, right? What are we missing? What would be good to add? Again, mechanically fastened 14, closed cell, spray foam, 27-page spec. Here's the big one we want to talk to you about right now. I'm not going to go through each one of those because obviously that'd be a really exciting presentation. One of the keys we wanted to talk to you about today is ABAA's here to help. Not only with education, but we don't want to be a one and done and gone. We want to help you guys throughout the year. We want to be part of your projects. We want to help you make better buildings. We really do. If you saw those numbers and you don't have that many pages in your specs, reach out to Peter. We actually have a sacrificial lamb, Peter. He's going to help you with your specs. He doesn't know that yet. Actually, I think we just sent him an email earlier this week and telling him. No, but Peter helps out. He does all of our trainings. Right, Matt? He helped with you with your training. He's our main training guy. Peter's been in this industry a long, long time. Reach out to him. Have him review your specs with you. See what you can add. Right? See how you can protect yourselves, how you can build better buildings. Please do reach out. Some things we're going to talk about with the specs, right, is that primary barrier. And Andrew talked about it, right? Thicken up that dashed line. I showed that one detail earlier where there's a bunch of, dashed lines all over the place. They're not easy to follow, guys, but that's the primary barrier. They have to be continuous. They have to go from one plane to the next. They have to go from roof to wall. They have to go from window to wall. Make sure that primary barrier is in there. Okay? In your details. Make sure we're talking about specifications. One of the things we're going to talk about with you guys with these specifications are the current codes and where things are at and what you need to meet. Do you have material specs? Do you have assembly specs? Whole building tightness. I just heard from Laverne, he's out of the room. They're looking to get the whole building air tightness testing in the IBC and IECC. Well, it's in the IECC already. In the IBC for the 2021. 3 years. They're going to get in the code. It's that important. There may be an adoption period. There may not. Right? They might do what England did, basically told the people in England, you will do it today. That was the end of discussion. I doubt in the U.S. they'll do it that way, but yes, sir.
Is there a relationship between air exchanges per hour and 2.0 liters per square meter?
You know what? I hate to say this, I'll have to ask Laverne on that one. So let's get that relationship. He can explain it much more thoroughly than I can. Okay? So, but you need to understand that these things are in there. These are how we know our air barriers and our buildings are working. These are the different testings we're talking about. And you have to know that's going to be in code. It's getting codified, plain and simple. That's part of what we want to talk about with specs. Would you rather be ahead of the curve or behind the curve? That's how I got involved with the enclosure stuff. The GC I worked for said we want to be ahead of the curve. Code compliance, if you're doing materials, this is what they do. They take a 3 meter by 3 meter, right, and they're checking it. Doing the air pressure differences, you're seeing how it leaks. Does it pass? Doesn't it pass? Pretty simple. Laverne was sitting at a code hearing meeting for a day right next to one of the testing labs. He wore the guy down. He got the guy to test peanut butter to prove a point. What do you guys think? A thin layer of peanut butter being tested as a material, you think it passed? Yeah, by over a factor of 10. So it absolutely passes. Yeah, what was it, chunky or it was, no, not chunky, it was smooth. But as a material, it passed for code. Nobody's going to use it, right? But that's part of the point where we're saying you need to do more than just a material test. You need to have more than just materials in your specifications, right? Does that make sense? We talk about assembly testing, right? The 2357, great test. But it is, again, it's a test. Everything's in plane. The window is plywood, generally. Right? I showed you a picture earlier today, and I mentioned about how do we get from this window that's way out here, tied back to this wall that's back here. So it's a good test, but again, it's not necessarily real life. But it's a good step. It's the best step we have to date to use. So we got to start somewhere. Okay? That's why we're talking all these different steps. We're going to talk about, again, whole building air tightness testing. These are getting easier and easier to run. They're using these small little fans they can place all over a larger building. They're doing multi-story buildings all the time now. Those fans get tied together, either Bluetooth or wireless or Cat5 to a computer, and my understanding basically is they hit a button, the test runs, and you're done. There's more than that, right? Setting up the building properly is the key. But this test, just so you guys understand, is coming. It's going to be in the code before you know it. Yes, sir? I'm sorry, what's that?
What's the remedy for a failure on that?
Well, the remedy for a failure, that's a great question, right? Fixing it. So in this case, that's part of the reason why I show this picture on the right. A lot of times when we're doing this whole building air tightness testing, they might try to do it when you do have a difference in temperature. So you can use infrared. And so you see where those air leaks are. Now you have an idea of where it is. Now maybe you can go from the inside and seal it up. That's part of what, thank you though, thank you for the softball. I'm going to hit this one. It's part of the reason why we want to have a quality assurance plan. Right? If we only test at the very end, man, you're using hope as your plan again, and good luck. I'm not a big fan on using hope to be successful. All right, and we're going to talk about quality assurance plan at the second part of this. Okay, thank you though. Again, specs, we're going to talk about that pre-install meeting, pre-construction meeting. I'm a huge fan of it, as you may have figured from the earlier presentation. You heard Andrew talk about it. Okay, you're going to hear Craig mention it. That's in the specs. We give you some language right there, right? We want to help you guys make sure you're successful with this. We really do.
Who do you typically see or recommend running that?
I'm sorry, what's that?
Who do you typically see or recommend to run that pre-install?
So the question is, who do I recommend to run the pre-install meeting? I'm going to be biased to my brethren, the CM, GC.
Do they typically take that on and do that well?
Those are two different questions.
Yes.
Do they take it on? Do they run them well? Okay. Take them on, yeah. Usually it's in the specs. You need to have this, and when you bid the job, it's usually they're the ones bidding that job for that work, so they should be taking it on. Running it well, it's an experience thing, right? First time I ever ran one, I'm sure it wasn't as good as today is what I could do. So,
I guess some of the ones that I've seen, people get together because they have to.
yep.
They just get together and are like, what do we talk about?
Well, and so back to that pre-installation meeting, there are templates out there. If you're looking for help on something like that, there's stuff out there that we can help you with. Right? And that's what we talked about earlier when I said, make sure you have all these people touching it Enclosure. You have the right people there. That meeting should go through different things like material compatibility. And I don't have the picture here. I show on some of my other presentations of precast walls with a low roof. And I show the sealant joints in that gap between sealants. Because one was a silicone that went in first and the other one was a urethane. Material compatibility. All these sorts of things should be talked about. There are templates out there that you can use to help you walk through these meetings. Okay?
That'll help people come prepared too, because otherwise they just
That's all part of it, right? They should be coming prepared with what they're going to be using, what type of materials they're looking to use. Absolutely. But if you have a template to follow, you can send that template out early and say, hey guys, these are things we're going to be looking at. Please come prepared. And you'll get 60 to 70% that will, and you'll get, that 30 to 40 that are going to wing it.
And this is all on that flash drive?
The pre-installation templates, I don't know are on the flash drive.
This is, right?
Our specs are. I'll be honest, this presentation I developed on Sunday. That's what I did for 6 hours while watching basketball. Okay? And part of the reason why is we had a different presentation and somebody else was giving it. And I'm not a big fan of giving other people's presentations because I can't tell my stories if I give their presentations. So again, this will be on the website in the next couple of weeks, this presentation. So if you wait a week or two and then go to the website, you'll be able to find it. If you give me your card, I'll get it to you. I don't care. All right?
But Brian, is there a presentation like this, the original one?
There is an original presentation on specifications on that flash drive, yes. Thank you. Okay. Again, surface prep, we want to make sure that you guys are talking about good surfaces for materials to go to.
Where'd you get this picture?
This is Laverne's picture, and I don't know if that was, I have no clue, but man, that's a hell of a job to keep those in, isn't it?
Yeah.
I don't even know how, yeah, priceless is a great word. I don't even know how in the world they kept that in. That is a heck of a picture. I don't even know what to say to that, right? I have adjectives I want to use, but I can't. Being recorded. So, we want to talk about, again, transitions, material to material. If you remember when my first presentation, I showed the old house, right? I said you had about 5 materials for that whole house. I think there's at least 14 materials on this one little foundation to wall transition. To reemphasize that point of how much we build with today and how things have changed. Again, window to wall, continuous. We got to make sure if that window's sticking out, how are we doing it? There's ways to do things. Got to make sure we do them right. We got to give products a chance to succeed. Right? Roof to wall. Andrew just went through a bunch of those. He did a great job. Make sure that line of continuity. Things are tying together. We need to make sure it's there. We want to have specifications that call for this. We want to have performance specs that require it. Okay? Penetrations, again, self-explanatory. We got to make sure any hole going through that we're sealing them up properly. Again, these specifications will help you guys with all these things. We're going to get into the quality assurance process. We're going to get a little bit more into what ABAA does. One of our big features is to make sure buildings get built properly. This education is one of our 2 main goals. The second is our quality assurance program. We want to make sure that the installers and everybody else and the owner is receiving what they're hoping to receive. A good building. My kids hate driving through Milwaukee with me. Yeah, some of you are giggling, you get it already. Because I was involved with a lot of projects in Milwaukee. And before that, before I was in the world of construction, my dad was on a lot of projects, so I used to go tours all the time from this big on up. Right? It's cool to see buildings that you were involved with 30 years ago. Absolutely. Right? That's what we want to give owners. Buildings that are going to last. Right? We got a couple fun ones here, right? Quality's not waiting for something, a defect to happen. I like this one. When I was a QA manager, I get calls from PMs at the end of projects, and I felt like that's what they were asking me. Hey, come on out, visit my site, tell me everything's perfect. Dude, why didn't you call me 6 months ago when we could have actually made a difference? Right? Gotta have some fun out here, right? You gotta throw some of these funnies out there. Deploy it, hurry up. Well, again, that's sometimes when you, if you're that QA guy, sometimes that's what you feel like. That's what people want. It's not how it works. What is the building code? Mr. Chris Mathis, a good friend of ours. He's going to be one of the keynote speakers for us in May at our conference. Chris is heavily involved with a lot of the codes, IECC and everything else. I'm going to give you his definition of what the code is, building code. I would like to hear what you guys think. What's the building code? What's that? Minimum standard. How about the crappiest building you can actually build without losing your license? Yeah. If you heard Chris, you know the answer. Pretty blunt. Pretty straightforward, pretty honest. Andrew made the comments, hey, when he started out, hey, stop the water. You can't stop the water. Why do you have a license if you're an architect? 2, stop in the air. We're at that point, guys. You should be able to stop the air on your drawings. We really are. Right? The building code is the absolute minimum standard of care. It's the crappiest building you can design or can be built legally. All right? Make sure you tell that to the owner when you talk to him next time. We're going to build just the code. Let's get better than code, right? Laverne made the comments this morning about the Army Corps and about the guy calling because he was in trouble, right? He did a building, he tested it, didn't work out, they had to go back and repair it. Hey, think about this. All over the country, they're hitting under that 0.4 for whole building tightness. The code is 0.4. Out in Seattle, they have to test every new construction building. They've had to for the last 2 years and record it and send it in. They don't have to fix anything yet, or that may have changed. I know they were talking about that. But they had to record it. And again, what they're finding out, even with the Army Corps, if your contractor's working for them, that first time you're doing it, yeah, it's kind of difficult. It's change. It's new. It's different. Nobody likes change. Right? The second job they do, they go, by the time they're done with it, they go, yeah, this wasn't quite so bad. By the third job, they're going, this is just the way we build things, guys. It's that learning curve, that S curve, right? It's not going away. We got to learn to do it right. Let's give processes and people a chance and products a chance to succeed. Alyssa. Didn't mean to wake you up. Just wanted to see if you're paying attention. How old's the baby?
Almost 3 months.
Almost 3 months. My daughter turned 13 on February 28th. 13 years ago, I slept on that couch. It was a birthing room. My wife gave birth, stayed in that room.
What's on the windows?
What's on the windows? Alyssa's asking, what's on the windows? Frost. The nurses would come in with dry towels and wipe up all the water a couple times a night and a couple times a day.
That's gross.
That's gross. I'm picking her. I'm not picking her. She just, she, new mother, right? And I knew that. Stop and think. The comment, that's gross. I literally slept on that couch. That's air leakage in a hospital. Horrible, right? You wouldn't want to be there as a parent, as a father, as a mother.
Looks like there's other stuff going on too.
Yeah,
That's the main stuff right in there, right? That's really, it's pretty sketchy looking. Right, gotta stop the air. That's what we're talking about today, right? That's what we want to help you do with specifications, help you out wherever we can. Laverne hit on the efflorescence. Energy. We talked about the energy calculator. Great graph from the Department of Energy, right? Where are we losing all this energy? This climate zone, they're saying 30%. How many of you own homes or pay your own utility bills? Sorry guys over there. All right, just a couple of you do, all right, yeah. If you're, I suppose you guys are a little older class, so you have your apartments and stuff. How would you like to reduce your energy costs by 1/3? It's good beer money. It's good beer money for me. I'm not just, you know, hanging out with that group over there. I need it. But it's, but seriously, I mean, we know that the gaps, cracks, holes, the energy loss is literally, you know, in this climate zone about 30% of your energy because we're not building it right. We're not building it airtight. Like Andrew said, we want to keep that conditioned air on the inside where we are, whether it's cooling or heating. Who cares? You're paying for it. Again, IR to help you see that. You know, this is a reclad again. You can see the existing, you can see the new. Good example. Let's fix it up. Let's do it right. Cost, I talked a little bit about Zurich. And you got the 10, you know, 110, 100 rule, right? People have seen that before, hopefully. Deming, quality assurance, things like that. Prevention, doing it right, getting the specs right to start with, getting the details right to start with, having some of these meetings, making sure they happen. The best call I get, right, when I was in the world of QA/QC was that project manager. Hey, we're closing out the job. They want meeting minutes from our pre-con meeting that we didn't hold. What do I do? Dude, why are you calling me? I'm sorry, my magic wand doesn't work anymore. Come on. Right? But those are literally, I mean, those are serious calls. But have it in the specs, follow up, make sure they're getting it in their schedules to have these things. Gentleman came up to me right before I started presenting and said, did you see the icicles outside here? I didn't. Don't know if anybody from here is here. But again, you have other ones, right? Good examples. We know it's air leakage. How would you like to build the building? Next season you come in, you drive by, you see that, and the owner goes, what the is this? Being recorded, I can't use all the adjectives I normally use. Right? That's real. I didn't go and Photoshop anything. Basement, we talked about basements and the moisture down there and make sure they're built properly and everything else. They put 6 mil poly from about 4 feet down. How do I know? I ripped it apart. That's again why my lungs are going to be so cool when my autopsy is. Right?
Only the bottom 6?
Only the bottom 4 feet, for whatever reason. That's all they put the poly on. And that's where we had all this major issue. There are ASHRAE studies. Ooh, I need to move that up. ASHRAE study 1478 went and looked at a lot of projects out there, seeing which ones were using QA/QC programs or enclosure consultants, and which ones weren't, and which ones, this was Army Corps number, which one were hitting those lines. Pretty cool. All of them with some sort of program was below that line. Majority of them without were above. It's a good representation of why we need to do this. Hope is crappy planning. Having a process will help you hit what you need to hit. The how, let's talk about it. You want to do a quality assurance program, you better have some backup with it, right? The research and development, we've talked on that a couple times. We have over like 30 items in the hopper at ABAA right now that we want to do research on. We know that we need standards and specs, we need guidelines, we need things out there that people follow, right? All these things, evaluations, good installers. So this is the ISO standard and the way that they'll look to do it. That's what ABAA follows. Okay? We're going to talk about really tightening in a little bit on the model that ABAA is looking at with good design, you know, and that's what we're here today talking about. Getting you guys some of the specifications that you can look at, offering to help you with your specifications. All you got to do is call or email them to Peter. That's it. I was told yesterday I didn't push that idea far enough. I'm trying to really emphasize it today if you can't tell. We want to help. Call them up, send them your specs. Let's make sure they're good. Okay? The education today, we went through how many of you got your license before 2004. You didn't talk about air barriers. That's why you're here today. Thank you for coming. Seriously, thank you. We know it's tough to take a full day to sit here today. Hopefully it was worth your time. Good materials. You can go on the ABAA website. We put all the evaluated materials on it. What does it look like? Hey, if you are a board stock, in this case, you have to meet certain standards. If you are factory bonded, you have to meet certain standards in order to be listed on the ABAA website. We call them evaluated materials, fluid applieds, mechanically fastened. You get the idea. We've got a bunch of these different areas, and this gives spec writers, this gives architects, and apples to apples to compare products. Right? Gives you guys a good idea of what's out there, what meets these standards. Good contractors. ABAA accredits an entity, a business, and it certifies installers. There's legal ramifications, rules, everything else. I just need to make sure everybody's clear on that. But again, here in Ohio, you've got 17 different contractors that have gone through the ABAA program, whether it's fluid applied, whether it's self-adhered, whether it's SPF. You've got guys, in order to do that, well, I'll get into the installers here. In order to do that, they send installers. These companies send installers. They're supposed to have minimum 2,000 hours before they even show up on the training. They go through 3 days, right, Matt? They do building science on what you guys have seen today. Why? It's important that these installers know why it's important they do their job. I love the 80-20 rule. I believe 80% of our guys out there, tradesmen, I don't care what you are, an architect, whoever, I believe 80% care. They're proud of what they do. I'm sorry, I do think there's 15-20% out there that just don't give a damn, they want to get paid. We're hoping to get that 80%. We're training people, we're making them go through this. Not only that, they have to do testing. They have to do hands-on to prove they can do it, or they don't get to be part of the ABAA QAP program. Okay? The primary barrier, that air barrier, the primary barrier. Matt, close your ears for a second. Hey, want to start an SPF company? Sure, why not? Yeah. All right, get on your phone, go on eBay. By tomorrow, we can be ordering the drums. We can have the pump being ordered right in a truck. So by next week, you and I can be installing.
Okay, let's go.
I've never installed it in my life. Have you?
No.
No. Oh.
Seen it.
Seen it? Yeah. I got a buddy who's got a job. He says we can go do it. Yeah? Which one of you out there want that on your job? You think I'm kidding? That's the truth in the United States. Canada, you have to be licensed. The United States, I can literally go and be an installer tomorrow. All I gotta do is find somebody to hire me. So on your projects, how are you guys protecting yourself to make sure you're getting stuff installed right? Right? This is an opportunity to do that by using qualified installers, people who have been proven that they know what they're doing. Remember I talked about specialist spray polyurethane foam. It's one of the few products we manufacture on site. It's a great product if installed properly. Right? Between Laverne and Matt, they could probably give you 100 ways for it to go wrong. A clog in a hose, you're not getting the 1-to-1 ratio. You're not getting it heated up properly. Right? Somebody turned the pressure too high. Who knows? Substrate was wet. Right? All these things that these installers get trained on to make sure they know in order to be part of this. That primary barrier. Am I emphasizing that enough for everybody? I don't care about the brick. I know you guys do for what it looks like. I don't care about the metal panels. You guys do for what it looks like. Those have no function for me on how that building works. I want somebody to install that primary barrier right. Documentation. Those installers have to fill out dailies. They have to do it. The auditors come out and check that. We're going to talk about auditors in a second. If they're not filling out their dailies, they're not doing what they're supposed to do, they can lose their accreditation and their certification. There's some teeth to the program. Quality control, again, this is doing the spray foam density test. It needs to be done. That's part of the dailies if you're doing spray foam. These guys have to do it. Audit versus inspection, right? Two different things in my world. I see inspections normally happening at the end of a project, and somebody's just kind of checking, hey, yeah, it's done, but what happens if it was wrong at that point? I was on a project, I sent over the window specs to my superintendent 6 months prior. I circled the area because there was a new type of window out. The install directions looked almost identical to the old windows except for one little clouded area. I highlighted that, sent it to my soup. Yep, he got it. we went out, 6 months later, tested those windows. 88 windows were installed. 1 day of testing, 4 of them failed. They pulled all 88 windows out. Real life, that sucked. I wish he had been audited. I wish somebody had come in early, talked to him. I just sent him the email, but I wish somebody had gone and said, hey, we need some testing early. We need to make sure things are going in properly at the beginning, right? Auditors, there's 2 in Ohio, and there's 74 around the country. These guys come out on site and make sure the installation is going in properly. These guys are trained. They have to go through training just like the installers. I called a national testing group to have that foam tested when I showed you that whole fiasco. The guy called me back, the lead testing guy from a national testing company, said, how do I do it? I said, never mind, I've got the kit, I can do it. I know the owner, he trusts me. And I called the owner, do you trust me? Yeah, okay, we were good. Okay, these auditors are trained, they know what to look for. Audit program, there's a sample of the audit report on your sticks. If you want to see what happens when these guys come out, they get you information back to your job to show what's going on, the good and the bad, bad, and the ugly, right? The whole idea of the audit is to get there early. It's kind of like Chicago voting, early and often. Get the guy in early. Make sure the stuff's going in properly right at the beginning. Okay?
We update that too.
And we update, yeah, we're in the process of updating it, absolutely. That's one of the technical groups at ABAA right now, is to make sure these audits get updated, that we're staying ahead of everything, right? Absolutely.
Hey, Brian?
Yeah.
Now, on a project, is the site superintendent or the guy on the site for the GC or the CM, do they know what a good job versus a bad job on the air barrier is?
So the question is, does a superintendent on the project know what a good air barrier job or bad air barrier job is? And the answer is, it depends, right? I was a superintendent. I want to say I knew, okay? But I can't, I mean, again, it all depends. A lot of times they don't, because they got the whole building, right? They're worried about everything going on and what's going on a month from now. They may not understand the intricacies, well, that's easy for me to say, of all these little details, making sure stuff's connected properly. They might not. They may have never been trained on it. And chances are most of them haven't been. But there are some good guys out there, and I don't want to throw all my brethren under the bus, because I think there's some really good guys out there who do care and do get educated. Okay? Kind of throw the fun video, the fun pictures up. We don't want pictures like this. If you want a quality assurance program, right, you got to ask for it in your specs. Right? If you're going to hire a commissioning consultant or enclosure consultant, it's usually in the specs. It doesn't just happen. It's got to be bid out properly. It might just happen if that owner has failures and a lot of issues and put it in later, but if it's in the specs, it's more likely to happen. Okay, put it in. We can help you with the language. What does it cost? In this case, if you're going to run a quality assurance program with ABAA, it costs $2,000 an audit, 88.5 cents a square foot. Remember the air barrier calculator I talked about? Where do you think that money came from? Audits help pay for part of that. Absolutely. Today, Laverne's from Winnipeg. I'm from Milwaukee. Craig, he's from Portland. Maine. Sorry, Maine. Portland, Maine. And then you have Andrew is from Detroit. How did we get here? ABAA, right? The education part. We want to make sure the education's out there. That's what some of those fees help pay for. Absolutely. Give you an example right here. 35,000 square foot air barrier materials installed is for 2 audits. Total cost to run the program is $7,000. If you're running the QAP, you have to use evaluated materials. You have to use certified installers. You have to have, no matter what size, minimally 1 audit for that primary barrier. Kind of important. Again, let's think about the cost after, if there's an issue. You have initial tests. If you're doing something at the end of a project and you have failures on windows, you got to demo stuff out. Remove things. You have a really, really expensive meeting with owners, architects, and usually these aren't the junior members. CMs, manufacturers. Marcy's not here. She would love that one. Right? We get called in. Everybody gets called in to these meetings. Those are expensive meetings. Very expensive. Right? You got to remove material. Then you got to test to find out where the issue is. You got to have a meeting to discuss the repair, because if there's failures, everybody wants to make sure the repair is proper. Right? Then you're talking rework. You got to test again to make sure that what you did was fixing all the leaks. You're shaking your head. You ever chase more than one leak?
Oh, and I'm just talking about revalidating it.
Yeah. I've chased more than one leak. We fix this leak. We think we're good. We test it. We go, oh crap, where's this coming from? Right? Another leak. Okay. Then you get to go and you eventually you get to rework it and get your final testing and reopen. That's costly. You want some sort of program that gets you right from the start all the way through a project. Does that make sense? The whole focus of the ABAA QAP is this. We want the whole project to be in this low risk, high profit area. Again, the contractor I worked for, we were a $1 billion contractor. About 70% was healthcare. We were doing this on our healthcare projects because we understand you have leaks in a patient room and the owner can't put patients in there, can't make money every night. Think they're happy? 90% of our work was repeat work with same clients and negotiated work. Right? You want to make sure you're getting stuff done right throughout the whole process. In summary, hey, I was here to help you. Hopefully I pounded that one home for you, Laverne. I gave Peter up as a sacrificial lamb earlier. Seriously though, we do. We want to help you out with your specs. Please call us, email us. As was said last night, call Laverne anytime, day or night, we don't care. Airtightness, we know it's possible. It starts with specifications and details, right? Starts with you guys out here. If you guys aren't specifying it properly, you're not drawing it properly, what are the chances it's going to go in right? Okay? Reliance on inspection only, that's too late. We've got to have a process through the whole time. And then again, the whole idea here of the QAP program is reduce risk. Make sure it's a successful project for everybody. So here's the question I have for everybody. Where's the air barriers? I had to deal with that for 3 hours. With that, thank you very much. We're going to transfer